There are some laws of physics we need to talk about. I'm sure you had them in high school. I'm sure you'll remember them. But what they are is, number one, high pressure travels to low pressure. Okay? Number two, heat travels to cold. Got something hot, it'll want to migrate to someplace cold. And the third one is wet travels to dry. If you have a place that's wet, it will migrate to a place that's dry. Nature doesn't like differences. It wants to make them all equal, and the wet will go to the dry, the high pressure will go to the low pressure, trying to make everything equal. Okay, so how does this affect us in the manufactured housing business? Well, it affects us a lot. For instance, let's talk about pressure. Let's talk about the crossover duct, for instance. Let's suppose that you have a big hole in the crossover duct underneath the home. Your furnace blower comes on, pressurizes the ductwork. Okay? As it pressurizes the ductwork, it's blowing air in it, and it's blowing out this hole. So what you're doing here is you are reducing the amount of air in the home. There's a difference between the air inside and the air outside, and you get this very small little difference. The total difference needed to have air infusion into the home is measured in pascals. Pascals are tiny, tiny, tiny little measurements of pressure. In fact, 15 pascals is all you need to create a little air infiltration into the home. A pascal is so small, it takes about 6,700 of them to make 1 psi, and your car tire probably has 30 pounds in it. So it's a very small differential of pressure. And if you're pumping air out of the house, you create this differential of pressure, and you'll have air moving into the home. Okay? And as it moves into the home, it'll have high humidity in it, maybe in the summertime, and it comes in and it strikes your air-conditioned inner wall, and then the humidity thing kicks in and it gets condensation, and I've seen houses ruined, houses just messed up awful all around all the light switches, because it's easy to come in 1,000 places around the outside. Siding's got all kinds of little holes in it. But through the interior walls, the easiest place to draw air in is around a window, a light switch, or an electric receptacle. So the house that I saw had all kinds of mush all around every receptacle. I thought, how in the world does electricity make water? Because it's all wet here, and that's a bad combination. It was condensation forming as the air came through the wall, and that's because high pressure travels to low pressure. Can mess up your house. Look for holes in crossover ducts. It'll make a big difference. If you have an in-floor crossover duct and you don't have that gasket good, you're going to mess it up, because it's going to leak. It may leak into the marriage line, get up into the roof cavity. But anyway, if you're pumping air out of the house, you're going to make a problem. Next one, wet travels to dry. This is simple. If it's wetter underneath your house than it is inside the house, well then, the water's going to want to go into the house. And it's going to get into the floor joists and turn them into propellers. It's going to get into the decking. Even if you got plywood, it'll eat it up eventually. It'll make them droop. Sidewalls will go down. The middle will get lumpy and expand. The drywall is liable to get little stains in it. You've seen them where ceilings right at the outside edge of the house have little brown, little half moons in them, because water went up through the house as humidity went up against the roof. In the wintertime, it was cold, condensated underneath the roof, ran down the underside of the roof, and then leaked into the wall. You know, oh, the house has a roof leak. No, not a roof leak. The water is actually under the home, coming through the home, condensating, and then remaining in the home and leaking into your ceiling, making the stain. It's the water under the home that's the problem, probably not a roof leak. And of course, if heat travels to cold, if you don't have a proper insulation, then you're going to lose your heat. I think it's pretty self-explanatory. But these are the three laws of physics that we're going to be relating back to as we go through this whole course, because they are the things that affect how these houses perform. We need to consider them, and we need to make sure we work in conjunction with them, or else our houses just aren't going to work.